Hi guys, my name is Clement. Today I want us to go into the physics subject, and under the physics subject we'll be looking into moments. This question I have here was written by my students as the end of November test, mid-November test. So the question says, calculate the unknown force A of the moment below, applying the principle of moment. So I give them this scheme diagram here, which shows a ruler imbalanced by this fulcrum, and we have three forces on different sides. We have two forces on the right side of the fulcrum, and we have one force on the left side of the fulcrum, and this ruler was balanced by all these three forces. So I want us to understand what the principle of moment is. The principle of moment states that the clockwise moment is equal to the anti-clockwise moment, which means that once you have a scheme diagram like this, the moment of the clockwise, which is this side, and the moment of the anti-clockwise, which is this side, they are equal. The clockwise moment is the one that goes this side, and the anti-clockwise moment is the one that goes this side. They are equal. So, in other words, we can say that the principle of moment is the principle of equilibrium. It states that for the objects to be in equilibrium, the clockwise moment have to be equal with the anti-clockwise moment. We call it the principle of equilibrium, and this is how we calculate the moment. Moment is equals to the force that is acting on that object times the distance of the force from the pivot, or the distance of that force from the fulcrum. So in other words, if we have this force here, which is 2 Newton, we see that it is placed 3 meters from the center of the fulcrum at the pivot. 3 meters from this, 3 meters from the pivot, and we placed the 2 Newton force. So which means for us to calculate the moment of this is going to be the 2 Newton, which is our force, times the distance of our force from the pivot. That's how we calculate the moment. So now we have this scheme diagram here. So we have to calculate the unknown force, the force that was able to balance this ruler on this pivot. The force was able to balance this ruler on this pivot. So we are going to apply the principle of moment, or the principle of equilibrium, which says that the clockwise moment is this one. The moment on this side, all of these forces and all of this distance, when multiplied and added together, has to be equal to the moment on the side. So this is how we are going to do it. This is F1 times D1. My F1 is this one, and my D1 is this one. You see, F1, D1, and here I have my F221, F21, F22. I have my F2, my D, sorry about that, and my D22. So which means that on the clockwise I took it as the second force, and on the anti-clockwise I took it as the first force. But we can do vice versa. You can take the anti-clockwise one as the second force, and the clockwise one as the first force. So what we did here, we said this N is equals to the Newton times the 4 of the meters, which is from the anti-clockwise side, equals to, because we say that they're in equilibrium, so they have to be equal to each other, equals to the force, the 2 Newton, times the distance of it, the distance of the 2 Newton from the pivot, which is 3 meters, plus the reason why we are adding them is because these two forces, the 2 Newton and the 5 Newton, they are acting on the same direction. They are both acting downwards. That's why we are adding them. We add them because they are acting on the same direction. So which means that is going to be 5 Newton times the 8 meters of how far the 5 Newton force is from the pivot. Then we add them, we get 40 Newton meters. And the Newton meters is the unit of the moment. The unit of the moment is Newton meters. Why? Because we are multiplying the Newton, the force, with the distance. We are multiplying the Newton with the distance, which is the meters. So that's why we have Newton meters as our unit. So, and then from there, you are going to solve it algebraically. You're going to solve for the value of A, which means that you are going to add the moment of this to 1, and you are going to add it to the moment of the 2. Then you end up with 46 Newton meters is equals to this one, the one that we are looking for, the force that we are looking for, and then you are going to divide by 4 meters both sides, and then you get 8, and then you get A is equals to 11.5 newtons, which means that the force that is required to balance this ruler here is 11.5 Newton, which means that the force that we need to balance this ruler is 11.5 Newton on the side. And remember that in moment is a force. It comes from the principle of inertia, the first law of motion of Newton's first law of motion, which is the law of inertia. So we have to know that in moments we are dealing with forces, we are dealing with newtons. So it is possible that instead of us giving you Newton, we can give you kg. Instead of this being 5 Newton, it can be 5 kg. So whenever you are given the mass instead of the force, you have to convert your mass to the force. And this is how we convert the mass to the force. We know that our weight, which is our force, is equals to mass times the gravity. Our gravity, we know that is standard, it is the Newton kg. It is the Newton per kg. It is the Newton per kg. And you have your mass here as 5 kg. So you're going to multiply them, and then you end up with your weight or of your force as 50 Newton. This is your weight. So instead of you using the kg, whenever you are given the kg in doing the force or in doing the moment, convert your mass into your force. And this is how you convert it. Weight is equals to mass times gravity. So this is what I have you guys for you under the moment. I'll keep on doing more examples on how to solve moments. Next time I'll do an example when you have opposite forces, when the other one is acting upwards. Thank you guys.